Hello everyone, welcome back to my channel where we solve advanced problems using basic concepts. This week we are going to be talking about probability. So now, what is probability? Probability is the event likelihood of choosing a certain outcome from a set of outcomes. The total probability is always 1. So the formula for probability is favorable outcomes divided by the possible outcomes. So let's just do a quick example here. I flip a fair coin once. What is the probability of getting heads? Well, we know that probability is favorable over total. I'll represent it as F over T. Now, what are the favorable outcomes? Our favorable outcomes is just going to be the heads. That is our heads case. How many heads are there? There's 1. There's 1 case for that. Then for total cases, for flipping a coin, how many choices do you have? You can have a head or a tail. So 1 head or a tail. How many cases are those? Those two combined are 2 cases. So that's 1 over 2. So our answer is just 1/2. Alright, now let's move on to some examples. If we roll 4 fair dice, what is the probability that all 4 dice show different values and all 4 dice show the same value? It's almost just like the coin problem, but a little bit more difficult. Alright, let's try it. So a good rule of thumb in probability is to always calculate the total outcomes first. Because probability, you really want to be organized, and starting with the total outcomes is a good way to be organized so you do not mess up any calculations. Alright, so let's calculate our total outcomes. For part A, all 4 dice show different values. For all 4 dice showing different values, let's think. We roll the first dice. How many choices are there for the first dice? There's 6 ways, right? Because you can roll a 1, 2, 3, 4, 5, or 6. So there's 6 ways for that. Then, what about the next dice? There's no restriction. You can again roll 6 different choices. Again 6 and again 6. This is going to be our total. And you realize that this will not change for part B because it's the same 4 fair dice. So this is our universal total right now. Now, all 4 dice have to show different values. So now I'll divide it up into part A. And I'll say that, okay, for favorable outcomes, all have to show different values. So how many ways are there for that to happen? The first dice, you can roll any single value. Let's just say you roll a 1. But then, can you roll any single value anymore? Can you roll a 1 again? No, because then that case would not be satisfied. You can roll anything but a 1, and there's 5 ways for that to happen. Let's just say now you roll a 2. Now you can roll anything but a 1 or a 2. So now there's again 4 ways. Let's just say you roll a 3. Now you have to roll something different. There's 3 ways for that to happen. Because you can't roll a 1, 2, or 3. You can roll a 4, 5, or 6. So let's just say you roll a 4. And this completes it. So now, this is our favorable outcomes. This is our universal total. So now we can calculate probability, which is favorable over total. Which is, in this case, going to be equal to 6 times 5 times 4 times 3. Divided by 6 times 6 times 6 times 6. So, we can do a little bit of canceling here. 3 will cancel with this to make 2. 2 will cancel with this to make 2. 2 will cancel with this to make 3. What do we have in the numerator? A 5. What do we have in the denominator? A 6 times 3, which is 18. So our answer is just going to be 5 over 18 for part A. Alright, now let's move on to part B. All 4 dice have to show the same value. Now we don't have to calculate our total again because our total we know is just going to be 6 to the power of 4. So all 4 dice have to show the same value. There are 6 ways to choose what value you want for the first dice. It does not matter. You can roll a 1 through 6. It does not matter. So let's just say you roll a 1. But now, can you really choose any other number now? All 4 dice have to show the same value, meaning that the remaining 3 have to be 1. How many ways are there for that to happen? There's only 1 way for that to happen. 1 way for the next dice, 1 and 1. These all have to be 1. And therefore, our answer is just going to be 6 for favorable outcomes. Now we calculate probability, which is favorable over total, which in this case is just going to be 6 divided by 6 times 6 times 6 times 6. This will cancel with this, and you just get 1 over 6 cubed, which is 216. Alright, now let's move on to a little bit more of a difficult example, coming from the 1987 AJH SME. 10 balls numbered 1 through 10 are in a jar. Alright, so we have our balls numbered 1 through 10. Jack reaches into the jar and randomly removes one of the balls. Alright, so Jack is reaching in. When he removes one, we don't know if it's with or without replacement, so we'll figure that out later. Then Jill reaches into the jar and randomly removes a different ball. Okay. Now we know that this is without replacement because Jill is removing a different ball. What is the probability that the sum of the two numbers on the balls removed is even? Alright, this is a little bit more complex. When we have this, let's go being organized. Let's start with our total cases as always. Our total cases, in this case, there's going to be 10 ways for Jack to choose which ball does he want. Then Jill has 9 ways to choose which ball she wants, which is going to be equal to 90. Alright, now let's calculate our favorable outcomes. For the sum of the numbers on the two balls to be even, how can we make that happen? Well, to make it even, let's think about it. Let's just say that Jack pulls out a 2 and then Jill pulls out a 4. 2 plus 4 is 6. 6 is even. So an even and an even will satisfy this. What about an odd and an odd? 3 and 5. That will sum to 8. So this also does satisfy. So odd and odd satisfies. But now what about an even and an odd? Or an odd and an even? It will not matter which. Even, odd, let's just say you choose 4 and 3. 4 and 3 will sum to 7. Is that even? No, it's not. So therefore, our only two cases here are even, and odd. Alright, so now let's get solving. Let's do our case 1. Our case 1 is going to be even and even. I'll enumerate that as EE. So, how many ways are there for Jack to choose a ball? He has to choose an even ball. So let's write our even numbers out. 2, 4, 6, 8, 10. There's 5 ways to choose which one does he want. When Jack chooses that, let's say he chooses a 2. Now Jill has 4 ways left. So our answer is just going to be 5 times 4, which is 20. Alright, now let's move on to our case 2. Odd and odd. Well, there are going to be, let's write out our odd numbers. 1, 3, 5, 7, and 9. There's 5 ways to choose which ball Jack wants. Let's say he chooses a 1. Then there's 4 ways again to choose which one Jill wants. 5 times 4 is again 20. So we add up our favorable cases. Probability is favorable over total, which is equal to 20 plus 20 over our total 90, which is equal to 40 over 90, which is equal to 4 over 9, which is our answer. Alright, let's move on to the final problem of the day. Let S be a set of permutations of the sequence 1 through 5 for which the first term is not 1. Okay, that's a lot to process, so let's write it down. Permutations of the sequence 1 through 5. How many permutations in general are there? Let's ignore the restriction about the first term not being 1. Well, there was just going to be 5. There are 5 spaces. There's 5 ways to choose which value you want here. Let's just say I choose a 3. Then for the next one, you have 4 choices. Let's just say I choose a 2. And then there's 3 choices. Let's just say I choose a 5. And then there's going to be 2 choices. Let's just say I choose a 4. And then there's going to be finally 1 choice for the final number. Let's just say I choose a 1. So there's 120 ways for our total. But is this really true? No. Why? Because now we have to account for our restriction. The first term is not 1. So now with our 5 spaces, how many ways are there to choose the first space? Oh, my apologies. There's 4 ways, right? Because 1, 2, 3, 4, 5, you can choose any number but a 1. So you have 4 ways to choose this. Let's say I put a 2. Okay, that means that then, what about the next number? Now 1 is allowed. So now 2 is gone, but 1 is allowed. So now you have, again, 4 ways. Let's say I choose a 1. Now you have again 3 ways. Then, let's say I choose a 3. You have 2 ways. And then finally, 1 way. And this is going to be equal to 96. So our total cases is 96. We know that. Now let's count our favorable cases. The probability that the second term is 2 in lowest terms is a over b. What is a plus b? Okay, so now we have a little bit more of a restriction. In our 5 spaces shown here, you are going to have exactly how many ways to choose the first term. It can't be 1. We already know that from our original. But can we have it now as any one of the 4? We cannot, because let's just say we choose a 2. Then can we choose a 2 for our second term? No, we cannot. So that's why in our set 1, 2, 3, 4, 5, you cannot choose a 1, you cannot choose a 2. You have 3 ways to choose the first term. Now, the second term, how many ways are there to choose that? The question is that probably the second term is 2. So there's only 1 way for that to happen. It's when it's 2. So there's 1 way for that to happen. Then, for our third term, let's just say put a 3 in the first spot. Now with our set 1, 2, 3, 4, 5, we've removed the 2, we've removed the 3. Do we have any more restrictions? We do not. There's just going to be 3 ways for the third number. Let's say choose a 4. 2 ways for the fourth number. Let's say I choose a 1. And then 1 way for the last number. We have to choose a 5 now. And this is just going to be equal to 18. So our favorable is 18. Our total is 96. Probability is favorable over total, which is equal to 18 over 96. You can divide by 6 on the numerator and denominator. You'll get 3 on the top, 16 on the bottom, which is equal to 3 over 16. Let's read our question again. What in lowest terms is a over b? What is a plus b? So when we have a over b as a equals 3 and b equals 16, our a plus b is equal to 3 plus 16, which is equal to 19, which is our final answer. Alright, thank you for watching this video, and I will see you in the next one.